Okay.
Yeah, so today I'm going to talk about an interesting topic that is suffix arrays. So that is pretty powerful data structure that is very that might be very important in many situations. So especially when working with strings. Um, and now, let's look at the basics and let's now talk about what is a suffix in terms of uh, programming, in terms of data structure. So in our case, a suffix is a substring at the end of the string or characters. So in other words, for our purposes, a suffix is a non-empty um, substring at the end of a string. So for our purposes, in our case, a suffix is a non-empty substring at the end of a string. So now let's look at the example. Um, so uh, yeah, um, for example, if we ask ourselves what are the possible suffixes of a string, for example, a string of for example the string horse, so we're able to come up with 5 unique suffixes. So that is e, uh, se, rse, orse, and horse. And so now we can say what is a suffix array, as we know what in our case is what is a suffix. So a suffix array is an array containing all suffixes in a sorted order. Or sorted all the sorted suffixes of a string. Um, so a suffix array, uh, that contains all sorted suffixes of a string. For example, let's look at the example. So for example, we want to look at word camel, for example, and yeah. So on the left we have a table of suffixes of the word camel. Um, with all suffixes of possible suffixes of the word camel, and on the right hand side there is a table where these uh, suffixes are sorted in lexicographical order. So uh, yeah, so the actual suffix array, um, to optimize the
No,
uh,
no, 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 no. Are you sure these are suffixes or are these substrings?
these are substrings. So these are suffixes. Yeah.
Here, I'll have to look up the definition because I think these are substrings. Because you're a suffix. Okay, well, I'll look up the technical definition. Okay, substring or suffix. Okay,
Mm.
interesting.
Okay.
I don't know myself. Okay, but I think these, to me, we used to call these substrings. We did not call
Okay.
these subs
Yeah.
in computer science. So, but I will give you the correct information because I am not 100% certain.
Okay. Yeah.
Okay,
Thank
so
you. Thank
maybe
you,
they
Robert.
also use suffix for this, but I don't, not as far as I know, but maybe.
Yeah. Yeah. Thank you, Robert.
Okay, go ahead.
Uh,
Go ahead.
yeah.
Sorry about that.
Okay. Yeah. Okay. So on the right hand side, the actual we can see that the actual suffix array or substring array would contain only um, indices of that are now highlighted in orange. These would only be indices where we won't store any words or these strings, substrings, whatever. But we are going to sort the suffixes themselves. We're not going to store suffixes themselves, but we're going to store their indices of a suffix in a sorted order. So in this example, we can see that if we're sorting the string, so amel, camel, el, al, mel. So they are going to, and we would take the indices on the left-hand side, and we would only store in the suffix array only these numbers 1, 0, 3, 4, 2a, 4, and 2. So that means that we are going to store only the array of indices, of associated indices, and an original string. And in this case, we can handle these pretty easily and without using additional space complexity, and that is pretty useful. Yeah, here it is. So the next thing is so here let's summarize what we've now got. So a suffix array is an array of indices, only indices. So these indices store the sorted suffixes of a string. So these suffix arrays were originally designed as space-efficient alternative to suffix trees. So suffix trees are containing sorted indices. The indices themselves, and it was less efficient than this implementation of suffix array. Yeah, and also another thing that even though the suffix array is very different from the suffix tree, suffix arrays are doing the same thing. They can do everything suffix trees can do, and also they can do some some additional information. They contain some additional information. For example, a longest common prefix array. So these arrays are very efficient in terms of not only space but also another information that they can store, because trees cannot store some additional information. And these arrays can, so they're much more efficient than trees. And also, as we've now started talking about longest common prefix, we are going to look what is a longest common prefix. So a couple of words about them. So this array, longest common prefix, is an array, or LCP array, is an array where each index stores how many characters two sorted suffixes have in common with each other. So, for example, if we have got two sorted suffixes, two sorted substrings, which we can handle using suffix array, we can figure out how many characters have in common. How many common characters are there with these substrings. So now let's look at the example to figure out what is a LCP array. So here we are constructing the suffix array. So we have a string AB, AB, BAB, and where we want to build a LCP array of this string. So first we're constructing a suffix tree, and then the very first entry we place in a LCP. The very first entry we place in the LSCP in the middle column is 0 because the index is undefined. So we can work with this index, and we're just ignoring it. And next, to begin constructing the LCP, since we have not started constructing it, we have not begun constructing it. We are going to look at first two suffixes, two first substrings that we have started, and figure out how many characters have they in common. So AB and AB have two common common characters, AB. So the LCP value for them is equal to 2. And now for the next string, the full string and the string AB, BAB, they are again their common characters. Again, two common characters, AB. So we're again placing 2 in the first index. So we place 2 again here in the common prefix. And now next we have the value of 2, and the next of 2 we have nothing common, so AB and A and just B, nothing common. Yeah, so the result, yeah. And now also for next two, B and BAB, they have one common syllable, one common character in the beginning, that is B. And yeah, next, oh yeah, one moment. So next, BAB and BAB, they have 3 common prefixes, and next, just one B common prefix. Yeah, so this is an origin. This is a common. These are the final tree LCP. That is a common LCP, the lowest common, not the lowest, yeah, but
common prefix, longest common prefix.
Yeah, longest common prefix. Yeah, just one moment. Yeah, so in purple, there is highlighted, yeah, a common a final common longest common prefix array. So that is the end of today's topic about LCP. So in summary, let's summarize. This LCP array is an array which tracks how many characters two sorted arrays, or two sorted suffixes, not arrays, but two sorted substrings or suffixes have in common with each other. So this LCP array can derive so much information, and that is very important, but not important, but very useful data structure. And also another thing, the first element in LCP is undefined, because we have nothing to compare with. We have nothing to compare with the first suffix, because there is no previous index for 0. But in most implementations, we're setting it to 0. And also, an important note that is very important in terms of time complexity, because the time complexity differs for many methods. So there exist many methods for constructing the LSCP array in O log n, O of n log n, and even O of n, that is the linear time complexity, which is just great time complexity for such an important data structure. Yeah. So next we are it is not changing the slide.
Oh, the slide. Oh, there we go. Okay.
Yeah.
Oh,
So
that's
yeah,
time complexity.
yeah.
Okay.
So we had such a table of these suffixes. So we have constructed this table and a final a LSP value and the summary. So
Okay.
so yeah, I'll wrap up here. Thank you, Robert.